there's some commonalities among the abduction stories, right? One of the things that struck me that maybe a lot of people don't know about, I was watching, and it was after the 2015 when I realized that these things I should be paying some attention. I was watching a talk by John Mack, a Harvard psychiatrist who started out studying abductions as a psychiatric problem, and then came to the conclusion that the explanation why these people think they're being abducted by aliens is really quite simple. They're probably being abducted by aliens. That was his conclusion, right? Which I found a little shocking. But watching one of his talks, I was stunned to find that, he had hundreds of abductees, purported abductees from around the world, from, Chicago, Congo, Nepal, everywhere. And their stories were that similar. One of the similarities that he mentioned really struck me, because this isn't something you're going to make up. And it wasn't widely known at the time. And it was the fact that 60% of the people, it was something like, don't quote numbers exactly because I'm not sure exactly what the numbers were, but I'm going from memory from what I saw in his talk. But he said something like 60% of the people who are abducted by what they describe as gray aliens are given babies to hold before they're taken back. And I remember him saying this. I was like, what? Are you kidding me?
Hey, Unexplained Ones, it's Dr. Mounce with All Things Unexplained. If you like our brand of truth-seeking, positive, paranormal podcast, then you can support the show at BigfootUFO.com. At BigfootUFO.com, you can make donations, find All Things Unexplained swag, check out all our social media links, and more. Another way you can help is wherever you're watching or listening, make sure to follow, comment, and share. The show would not be possible without your support, and we appreciate every one of you. And now, Professor Kevin Knuth.
We know now that in the early years of the 20th century, this world was being watched closely by intelligences greater than man's.
Did the CIA write Wind of Change by the Scorpions?
As humans busied themselves about the various concerns, they were scrutinized and studied.
Dr. Loeb, what percentage chance do you give it that you have indeed uncovered extraterrestrial or non-human technology?
With infinite complacence, people went about their affairs, yet across an immense ethereal gulf, intellects vast and unsympathetic drew their plans against us.
Prior to your abduction, did you believe in UFOs or any sort of alien life form?
All things unexplained.
So some of that, I think, sir, we'll save for closed session.
Hello, all you unexplained ones out there. Thank you for joining us. We are so lucky to have with us on this show Dr. Kevin Knuth.
And I have to say, Dr. Knuth, I really appreciated your article, Are We Alone? The Question is Worthy of Serious Scientific Study, because you really took into account, I think you called it the culture of UFOs, right? Like you did not ignore all the aspects of UFOs, and I appreciate that. We've had scientists on before who are very narrowly focused, and you can understand that, but besides the data that they collect, there is nothing else, right? They don't consider anything else. But here you were openly taking into consideration and acknowledging these other aspects of ufology, like UFO abductions, for example.
Well, thank you.
And so I really appreciated that.
Thank you. I think that a lot of scientists will fall back on the idea that, well, this isn't scientifically collected data, so I can't deal with it. And to some sense, in some sense, they're right. I mean, you're not going to publish any research papers about this because it's not scientifically collected data. But it's, and I think this is coming from an insecurity or, that they feel dealing with this type of topic, that this is a taboo topic. But the fact is, you can learn from information. It might not be what we scientists would call data, and sometimes people call it anecdotal data or anecdata for short. But we do learn from anecdotes, and you can learn things from anecdotes, and you can sometimes believe what people say. People sometimes tell the truth. I mean, that's just all there is to it. And I've heard scientists say, well, you can't just listen to what people say. And I think, why not? I listen to what people say all day long. And so do you.
Right.
And you can't function in daily life without believing what people tell you. And I don't just disbelieve when something weird happens or fantastical happens. And most of us don't. And this is how we operate. And to not pay any attention to these things as a scientist is problematic. Yeah, you can't use it to do detailed work. That's true. But you can use it to get to the point where you realize, well, this is interesting because there's some commonality here, and there's some commonalities among the abduction stories, right?
Mm-hmm. There sure are.
One of the things that struck me that maybe a lot of people don't know about, I was watching, and it was after the 2015 when I realized that these things, I should be paying some attention. I was watching a talk by John Mack, a Harvard psychiatrist who started out studying abductions as a psychiatric problem, and then came to the conclusion that, yeah, well, the explanation why these people think they're being abducted by aliens is really quite simple. They're probably being abducted by aliens. That was his conclusion.
Yes.
Right? Which I found a little shocking. But watching one of his talks, I was stunned to find that, he had hundreds of abductees, purported abductees from around the world, from, Chicago, Congo, Nepal, everywhere. And their stories were that similar. One of the similarities that he mentioned really struck me, because this isn't something you're going to make up. And it wasn't widely known at the time. And it was the fact that 60% of the people, it was something like, don't quote numbers exactly because I'm not sure exactly what the numbers were, but I'm going from memory from what I saw in his talk. But he said something like 60% of the people who are abducted by what they describe as gray aliens are given babies to hold before they're taken back. And I remember him saying this. I was like, what? Are you kidding me?
Alien babies or human babies?
No, well, that's all mixed up. Sometimes they're human babies, sometimes they're not. The people aren't quite sure whether they're human babies. And so it's not clear what's going on.
This lines up with what Robert Salas told us too.
But it was 60% of the people out of hundreds all say this from around the world. And I thought, there is something to this. I mean, this is the type of correlation where a scientist then ought to be paying attention, and they don't. They say this and they think, well, nonsense, and they turn it all off and don't look. Right? Don't look through the telescope. This is where the Galileo project gets its name. From the bishops who refuse to look through the telescope. Don't look because it's nonsense. But it's not nonsense. There's something to this. And yes, could it be a psychiatric disorder? Maybe. That's what John Mack was trying to investigate. And his conclusion was that it wasn't. That caused a lot of trouble for him.
Robert Salas actually was abducted. I don't think many people know that. When he told us on our show, he was very hesitant to tell us his story. And he did tell us his story. And it was shocking. It actually really changed a lot in my own brain and caused a lot of disruption in my sleep and in my life for some of the things that he shared with us, and trying to wrap my head around it, and a lot of fear, honestly, after he shared what he shared about kids and abductions.
What's interesting is that what I found now that I've been working in this field is that when you get to know some of the other serious people, other scientists even, or military people who have have interest in these topics, um, a surprising number of them claim to have been abducted, and a surprising number of them have had paranormal encounters as well. I mean, there's again, something's weird going on here. I don't know what that is. I've not been abducted. Thankfully, I don't want that to happen. It does not sound like fun to me. Um, but there's some weird commonalities here, and this is where the UFO phenomenon touches on these, weird paranormal like connections. These weird connections that people really can't explain and make everybody uncomfortable. They make UFO people uncomfortable. There's how do I deal with this sort of thing? Because being a real scientist is, a professional scientist, the way I deal with this to remind myself there is just real mystery here. This is a topic that's broad, that's never ever been carefully studied, except by maybe a handful of people whose findings are strange. I try to see this as opportunity rather than something you want to run away from.
We had the very talented Patricia Cornwell on our show recently. She's an author. She's written many books. And she said something that struck me, similar to what you're saying in terms of scientific study and what have you, is that she doesn't believe in magic. She just believes there are many things science hasn't answered yet. We just don't have the science for it yet. And if we don't have scientists like yourself trying to figure it out, we will never have the science for it. So we do need more people like you on the ground studying these things, trying to figure it out.
There's a lot we don't understand. And I think that is what gets lost on many scientists. I mean, it's not part of our education. I mean, the way, especially as a physicist, the way that you learn physics is we know this, we know this, we know this, we know this, and look at all these great people who figured out all these great things, and that's what you learn. You don't learn what's not known. You don't learn, about those types of things. You learn what's known, and in fact, it's such a strong, almost indoctrination. And it's not. The word has many negative connotations, but it turns out to be almost an indoctrination but that's just the way it's taught. I mean, you're teaching the field of physics is complicated and it's built up from small pieces, and you teach it on how you teach it in the way that it's built up. That's the best way to learn it. But it gives you the impression that everything's known. And it was, for me, such a big problem when I was applying to graduate schools. When I was in my senior year in college, I remember telling my parents, thinking, I don't know what I would like to study. Everything's been figured out. I don't know what to do.
There's nothing left.
And there's nothing to do. And I was interested in general relativity and space-time and that. And I said, but Einstein did it all. And these guys did it all. But the fact is they didn't do it all, right? And there are big questions, and I can list many of them that physicists will agree with aren't known. I mean, we don't know how gravity gets along with quantum mechanics. That's a big unknown. That's a huge unknown. We don't know why there's four forces, the electromagnetic force, the weak force, the strong nuclear force, and the gravitational force. We don't know why there's four. We don't know why there's 3 dimensions of space-time. These are all big questions, and there's a lot that's not known, and there's a lot that we know isn't known. But then what never gets asked is, what is there that's not known that we don't know about, right? And so when you start digging into some of this weird stuff, UFOs and the associated phenomena, you realize our knowledge is a lot like Swiss cheese. You know,
There's a bunch of holes in it.
we literally walk around the holes and say, oh no, it's all perfectly fine, and we don't look into the holes. We try not to look into the holes, and I think that's part of the problem.
That's great.
There is a lot we don't know about the universe, and
there's a lot that we don't know about. Yeah.
I think that's true too, and I think that scientists don't like to acknowledge such things, and it's not part of our training, and I think that's a problem.
Of the things that we know that we don't know, is there one that you would like to see answered or solved in your lifetime?
Oh, I was going to say I don't know.
All of
but
them.
That would be funny. Of the things we know we don't know, well, I just finished up 2 theoretical papers, which I'm going to submit for publication tonight. They're not even on the archive yet. But we actually have a derivation of why it ends up coming out of it as being part of that as being why space has 3 dimensions.
Okay.
And so I'm going to actually submit that to a journal tonight, and we'll probably put that on the archive in the next week or so. But the interesting aspect of these 2 papers, so these are pure physics papers, nothing to do with UFOs or any other weird stuff.
Sure.
But the idea is that came from thinking of mathematics as a technology rather than something that's discovered. Mathematics is a human invention. And if you're going to assign numbers to things, and why do we assign numbers to things? We assign numbers to things so that we can rank them, right? We can tell whether one thing is bigger than another. And so if you're going to do this, then it turns out that there are, when you have certain symmetries in how things are combined, then those symmetries are going to dictate how the numbers have to be assigned so that it's always consistent. And that's why mathematics works. And that's been a big question. That is a question that people don't realize. There's a wonderful paper by Eugene Wigner, a physicist, called The Unreasonable Effectiveness of Mathematics. And the question is, why does math work? And you realize that when you start digging into this, that it's not at all obvious that math should work. There's some wonderful quotes, and this is where I cheat. I'm actually opening my paper, and I'll read a quote.
Hey, this is breaking news for us. We're getting
preview.
an advanced reading of this paper that hasn't been published
This is
yet.
going to be a quote from Richard Feynman, and because he summed it up really nicely, and summed up the mystery nicely. And these are things that we don't understand, that aren't appreciated. And I just opened the PDF file in my LaTeX editor, which is not what I'm to do. The scientists who are listening would know exactly what I did wrong. And probably giggle at it. But yeah, so let's see, where is Feynman in this? Oh my God, how am I not finding this immediately?
Oh, good. I don't know. Did you guys hear my computer ring earlier? Like the phone rang on my computer. Did that come through the microphone?
I didn't notice
No, I
anything.
did not.
Oh
hear that.
gosh, I didn't know my computer could do that. First
Right,
of
but
all.
here's a really great quote from Feynman from 1967 that I found. So the paper, there's 2 papers, they come in pairs. So the first paper basically outlines why we use mathematics in science, and basically sets the mental stage on how to think about mathematics differently. And then the second paper actually applies that to derive. We actually show that the mathematics of relativistic quantum mechanics has to be the way it is, which is shocking that you can actually get it so simply. So Feynman wrote, "I find it quite amazing that it is possible to predict what will happen by mathematics, which is simply following rules which really have nothing to do with the original thing." And when you think about that, that's kind of amazing. I mean,
Yeah.
I remember doing this as a graduate student. I was taking quantum field theory, which is an advanced graduate class, and the final homework problem, which was horrible. It was we were given a month to do it. I was at the University of Minnesota. We were given a month to do this, and we were to calculate the cross section for a collision between a positron and an electron in a collider, which is basically what's the probability that they'll collide and interact. We had to calculate this, and we had to do it by hand. The professor wouldn't let us to do any of the integrals using integral tables. We had to do the calculus all by hand, everything by hand. And I remember he gave us the assignment, and I don't want to say his name online, but it was fantastic. I mean, looking back, it was fantastic, but it's horrifying. He said, it will be pages and pages and weekends, and I will assign it, so you ought to get started right away. He gave us this assignment in early November, and it was due in December. And it was pages and pages. Mine was 65 pages of calculations long.
What if you mess up a calculation, though? I mean, how do you figure out where you went wrong?
And you do, and I did.
Oh.
I was off by a factor of 2, and I could not find that factor of 2, and he gave me an incomplete for the class because I did not solve the problem, which meant I had to go back and figure out where that was, and I resolved that problem, I don't know, like 5 or 6 times over the course of a year and a half. And then finally, he just let me go. I said, just give me an F or something. I don't care. At this point, I don't care. But yeah, it's hard to do. It's hard to do that by by hand, 65 pages. But
that's insane.
But it was, while you're working on that, you're thinking, all along thinking, there's no way I'm going to get the right answer. And it's obvious, how is any of this math related to physical reality? How is it that 65 pages of math can actually tell me what's going to happen in a collider? I mean, and we don't really think of that as students, maybe until you're doing a problem like this. And but it's not obvious why the math works.
But it does work, and it works everywhere.
Right, and it always works.
It's beautiful.
It works everywhere. Why? So that's really what our first paper is about. Why math works.
And this is something Tim brings up. Sorry to interrupt you. Tim brings this up all the time, that if we are going to somehow contact some type of other extraterrestrial beings, the only way that we will be able to communicate with them would be through math.
That probably is one of the only ways we'll really be able to communicate. I would agree that probably would be the best way.
Yes. All right, Tim, take us to the next part. What else were you wanting to dive into here?
I just want to say, and by the way, we're talking to Professor Kevin Knuth. You've seen him on Encounters on Netflix. You've seen him on A Tear in the Sky. I rented Tear in the Sky on Amazon via Gaia. I'm not exactly sure how that worked still exactly, but it worked. And I was also told that you can watch it on the Roku channel, A Tear in the Sky.
That's where I watched it.
Yes, and after I rented it, I found out it was for free on the Roku channel.
And now you get to hear him on All Things Unexplained.
It was money well spent. I really enjoyed both of them, and he's here with us tonight, and we're so appreciative of him. And speaking, Dr. Knuth, of your television appearances, I feel like this scientific paper, launched your television career. I might be wrong, but in 2019, you wrote a little paper called Estimating Flight Characteristics of Anomalous Unidentified Aerial Vehicles. And it is an impressive paper, but you get into the 2004 Nimitz encounters off the coast of California. Can you remind our listeners and us as well, and it would be great to hear in your own words, what happened on the Nimitz?
What happened? I don't know if I can say what happened on the Nimitz, but I can tell you about the speeds and accelerations of the objects that they observed. To do those calculations as being a first pass of what I might be able to do as a physicist. So this was 2019 I was published, so I was already working on this in 2018, probably the summer of 2018 or so, or actually probably would have been in the spring. And that's shortly after the ATIP program is revealed in the New York Times article. And I thought, well, as a physicist, what can I actually do? What can I don't have solid data from anybody, but are there cases where I can estimate something? from the data. And I realized, especially in the Nimitz case, that there were a few examples where there were the descriptions of the events were sufficiently detailed that I could at least estimate speeds and accelerations. And so that's what I had started to do. I had done that, and then I went to the meeting, the SCU meeting, the Scientific Coalition for UAP Studies, which was in Huntsville, Alabama. And Robert Powell and Peter Reale had done their own analysis of the 2004 Nimitz encounters. And they were getting similar results that I was. I mean, we were doing the calculations that any scientist ought to be doing. We agreed, and I realized, I thought, this really just needs to be written up as a scientific paper at this point. We probably can do this. And so I teamed up with them. I didn't want to, especially after having seen their presentation on their work, and I had already done some work and knew that it was similar and I was getting similar results. I thought, well, I can't really go and publish a paper without including them. That would not be cool. So I thought, in fact, it's better to team up because we can use different techniques and compare and both, check each other's work and all of that. So we teamed up and we wrote this paper. The Nimitz encounter is interesting because you have a few different ways in which the tic-tac shaped objects were encountered. First, they were observed by Senior Chief Kevin Day, who was a radar operator on the USS Princeton in the Nimitz carrier group. They were located off the coast of Southern California at the time. And Kevin Day had been observing these objects on radar for, I think, a little around 2 weeks. They would drop in. They would appear on his radar at about 80,000 feet. That was basically the ceiling for his radar. And usually in the vicinity of Catalina Island, which is off the coast of Southern California, near Laguna Beach, which is where we filmed A Tear in the Sky. We went back to that location to try to collect data for that reason. But they would appear on his radar at 80,000 feet, drop down to about 28,000 feet, and then they would cruise south along the coast at a very slow speed, around 100 knots or so 120 miles an hour, something like this, which at 28,000 feet, there's not that much air, so an airplane can't fly at 100 miles an hour at that altitude. You fall out of the sky. So the speeds of these objects were way too slow, and that really bothered Kevin Day. He thought, these aren't just airplanes, these are strange things. And eventually, and there were times when they would drop from the 28,000 feet height to sea level, and would do so in about 0.78 seconds. So it would take 3/4 of a second for it to go from 28,000 feet to sea level. That's about 5 miles of height.
Yeah, that makes no sense.
3/4 of a second. That's shocking.
Mm-hmm.
And I thought, well, that I can do something with. I know the height. I have some idea of what the errors are going to be. I don't know the precise errors of the equipment, but I can estimate what they probably would be, and I can give you an estimate for the speeds of and accelerations. And if you do that, the accelerations turn out to be about the minimum acceleration. So the minimum acceleration, there's two extremes that could happen. You could instantaneously accelerate to whatever speed you're going to travel, and then travel at that constant speed to the bottom, and then just instantaneously stop, right? Now, that's in that case, I could calculate that speed. So that's one situation. The other situation is that you would accelerate at a constant rate to the midpoint and then decelerate at the same rate to stopping at the bottom. And that gives you the minimum acceleration. And I thought, well, that's the most useful thing to estimate. Because then I can confidently say these things at least had to accelerate at this rate. And we know this. I mean, it's indisputable. I mean, it'll be indisputable. So I thought this is the solid thing to calculate. And if you do this, that acceleration is about 5,600 Gs. Is the mean acceleration. So that's 5,000 times the acceleration of gravity.
Goodness.
People aren't going to survive this. People can't survive more than about 11 Gs for anything over a few milliseconds.
Right.
Our equipment can't survive this. An F-35 fighter will have its wings ripped off at about 13.5 Gs. Missiles can survive a bit higher. accelerations. They can maneuver up to about 30 Gs, and the airframes can handle maybe 60 Gs, but that's it. I mean, but we're talking these Tic Tacs were accelerating at minimum 5,600 Gs.
Goodness.
Can I ask something about that, Professor Knuth?
Yeah, of course.
What does that tell you about the mass of these objects?
That it's not clear at all what's going on. You aren't going to be able to accelerate a physical object at those rates in the conventional sense, because you're just going to break all the equipment inside. You'll be destroying the craft, which clearly isn't happening. So that's so already very strange. So the point of the paper basically is to highlight that, given what was observed, this is clearly anomalous. We don't have an explanation for what's going on. The other main point is that if you're going to accelerate halfway and then decelerate, that means at the midpoint you're going to be moving at your highest speed. And you can estimate what that speed is, and that turns out to be about 45,000 miles an hour.
Just a casual 45,000 miles.
Now, our orbiting spacecraft, the space station orbits at about 17,000 miles an hour. So when the space shuttles would come in, or Apollo would come back in, after a trip to the moon, you're coming in around 17,000 miles an hour. And you're a fireball, right?
Right, burning up. Yeah.
Fireball. Sonic booms, fireballs, the whole works, all the histrionics of the interactions with the air. The Tic Tacs weren't doing anything like this. There were no fireballs, there's no sonic booms, nothing. And then as a physicist, you worry about other things. Where does all this energy come from? How much power did it take to do this? Where did the energy go when it stopped? Energy doesn't, as it's moving, it's going 45,000 miles an hour at the midpoint, which, by the way, is the speed of the New Horizons probe that passed Pluto in 2015. That's moving 45,000 miles an hour. That's how fast the Tic Tacs were going, which is shocking. But where does that energy go? It should then, what is it? Half of 3/4 of a second later, 3/8 of a second later, it just comes to a dead stop. That energy had to go somewhere. We tried to estimate that energy. The Tic Tacs were estimated to be the size of an F-18, and we took the mass of the F-18 and then divided by a factor of 10. Say, let's pretend that the Tic Tacs were 10 times less massive than the F-18, just to get try to be a little more reasonable, because what's going on is shocking. And if you do that, the power it would have taken to make that maneuver was something like 1,300 gigawatts of power. That's way more than the nuclear power output of the United States.
What?
Yes, in the little Tic Tac the size of an F-18. Doesn't make any sense. How much energy got released when it stopped? That would have been about 250 Tomahawk cruise missiles going off at once. That should have been dissipated somewhere. The energy has to go somewhere. Wasn't observed, right?
Yeah, and we're seeing none of that.
You're seeing none of that. So these things are anomalous in many, many ways. The speeds and accelerations are anomalous. The lack of interacting with the air is anomalous. There's no sonic booms, no fireballs. The energy just seemed to appear and disappear. We don't know where the energy is coming from or going. So that was really the point of the paper, is to highlight that these things are really anomalous. This is not normal anything going on here.
Yeah. Well, I thank you for sharing that, because I think just as a casual observer, you just see things in the sky and you go, oh, okay, that does seem different. So to get that whole physics perspective of it is really important. I do want to take now your physics perspective.
Maybe I can add one thing quickly.
Yes, please.
That's relevant. The other question that came up is, are they spacecraft, right? Are these things really spaceships? And I just had a collapse of all my papers here.
Uh-oh.
Deal with that later. And no problem. So it was precariously balanced. I'm getting excited, so I'm
Yeah,
bumping
that's
my.
the next year's worth of
It'll
papers
be
right
fine.
there.
It'll
I
be
hope you
fine.
didn't need those in order to publish tonight.
All right, so yeah, so the question is, are they spacecraft? Well, I've already mentioned that they move at least in that example was moving as fast as the New Horizons probe. But at thousands of G's of acceleration, you can get to extremely high speeds pretty quickly if you can keep that up, right? So in the case of the Nimitz encounter, it would have only been accelerating for 3/8 of a second. But if you can keep that acceleration up for 17 hours, you'll be going at 90% the speed of light,
Oh man, which would make, of course, time travel or travel.
which gives you interstellar capabilities,
Right.
really, because you're moving at relativistic speed, so time is going to go slower for you. And at that acceleration, you can get across the galaxy in about 3 months.
What?
Your time. Across the galaxy, 3 months traveler's time, not the time
Okay,
for the
okay,
for the people everybody in the galaxy sees it will take about 80,000 years.
okay.
But for you, the traveler, it'll take about 3 months. It's a 3-month trip.
All right. This is where that movie Interstellar blew my mind, was the space-time continuum and learning about how a certain length of time and once.
Yeah, time is not the same for everybody. that's really difficult. Yeah.
Yes. Yeah, that was really eye-opening for me.
And I tell you what, I look at the speed of light so differently now when I heard somebody speculate that, you know what, if we are living in a simulation, then the speed of light might be the boundary that keeps us all in the simulation.
Interesting. Right. Interesting. And
Oh, that's okay.
And so what if it's the creators of the simulation that of course can escape that boundary, but they're the only ones that can.
it's tough because our theoretical paper that were published that I'm submitting tonight is in there we show that there has to be a maximum speed. You can actually prove there has to be a maximum speed, which is interesting because when Einstein derived relativity, that derivation depends on the assumption that the speed of light's constant for all observers. And instead, we're able to derive relativity and also independently show that the speed of light's constant for all observers and maximal. So it's interesting.
Let me ask a mathematical question there. So one of the things one of the pieces of mathematics I love is we can't really fathom what it means to do something like approach infinity, for example, but mathematically it happens. But what that means in reality is not so easy to understand. So when you do the mathematics on something like that, do the mathematics show it reaching or exceeding the speed of light, or does it show it approaching this limit, which is the speed of light, but never quite reaching it?
So the mathematics shows you can approach it as a limit, but not exceeding. Yeah.
The speed of light.
Right.
Okay, and when you say maximum speed, you say there has to be a maximum speed.
Which I don't like using the phrase speed of light. It's unfortunately we call that the speed of light because it leads to some confusion because light can slow down when it goes through medium. When light goes through my glasses, it slows down. Right.
Okay.
So the speed of light's not, and light gets bent by gravity. So gravity is also changing the speed of light. So that's a bit confusing. But what we in special relativity call the speed of light is better called the maximal speed. It's a maximum speed.
Okay. So just to clarify for my brain, you are essentially saying that anything in the universe, there is obviously a maximum speed that no matter what technology you have, you cannot go beyond this hypothetical speed.
By moving. I mean, be careful. Moving. No.
Okay. Oh, all right.
warp bubbles and things like that are a different ball game because you're not actually not moving in a conventional sense.
Gotcha.
So that's a different ball game. But if you're talking about motion, then there's a maximum speed, and the reason is because space and time are related to each other.
Right.
When you're 4 light years away from Alpha Centauri, you're 4 years away from Alpha Centauri, and that there's a relationship between the two, and that's why there's a maximum speed.
Okay.
And it all goes back to the math, right? The math says you can't do it. And so As far as we know, we can't do it. But I would be remiss, Dr. Knuth, if I didn't ask you, do you have any theories or wild speculation or favorite conjecture for the nature of these Tic Tac anomalies?
I don't. They have to be, they're not moving in a conventional sense. They're not moving in the way that we think of in terms of Galileo and Newton, or even Einstein relativistic motion. I mean, the accelerations are way too high. You'd destroy the insides of the craft. So whatever they are, it wouldn't work. So they're doing something totally different. Whether they have a warp bubble and are moving through a warp bubble like an Alcubierre warp drive or a version of that, or whether they're teleporting in some way, maybe bunches of little teleportations. I mean, at this point, I'm only making things up and guessing, but that's only because they can't be doing it the conventional way.
So I want to take all of this physics that we've discussed and bring it back to sort of the human experience of what happened on the Nimitz and the correlation between what happened there and what happened on the Maelstrom Air Force Base. So from watching A Terror in the Sky, I learned a little bit more about what happened to some of these people who observed these Tic Tacs. And the one gentleman, I think you mentioned him earlier, it sort of ruined his life. He was tormented by his
Kevin
peers and
Day,
colleagues.
yeah.
Yeah, and also somebody came on that ship and took all of the video footage and left. So same thing happened at Maelstrom.
So that's the point that gets, and that happened at Maelstrom too. I wasn't aware of that, but I'm not surprised.
Yes. At Maelstrom, the day after it happened, the black suits came in there. They separated every single person and pretty much said, you face life in prison if you speak about this to anyone, not to your family and friends, to anybody that is here, anybody that works here, anybody else that saw it. Nobody is to speak of this event ever again, or we will ruin your lives.
I mean, this is a story that keeps coming up, and this is the type of threats that Grush has talked about to Congress under oath, and it's a problem. This is democracy.
So I guess my question is,
Yeah, right. Yeah.
I just got really heated about that. Why? What do you think is the why behind the government's reasoning for taking all of this information and keeping it secret?
That's tough. There are probably multiple reasons, and some of them are not very good, but are practical, and others are better than others. I think that, so this has been kept quiet for. I don't like using the word secret because it invokes the idea of a conspiracy theory, which then you're blamed for. You're accused of being a conspiracy theorist. I don't think it requires a conspiracy to keep this quiet. Really only have to make fun of it at some point, and everybody giggles and forgets about it because it makes people uncomfortable. So it doesn't take a lot to keep this quiet. And in these events, these specific events like Malmstrom or the Nimitz encounters, all you have to do is threaten a few people and they'll stay quiet.
Yeah.
I was pointing out in another podcast recently, they asked me about Roswell, and I pointed out that the sheriff had gone out and independently investigated the area, and the military detained him for 5 days and questioned him and threatened him. Why? Well, good question.
And that's hard
question.
To explain over a weather balloon.
Right, yeah.
Exactly.
Yeah.
And of course, they changed their story from a weather balloon to something else, so that means they lied about the weather balloon. So the government has lied repeatedly in that situation. And I often point out that the only story that's actually believable is the first one, which was put out the day after it was discovered, and the government quashed it, right? But the local Air Force base put out the story that they recovered a disc. And that's probably the correct story.
Yeah. It's like the real version of Men in Black.
Because we know they lied about the weather balloon. We know they lied about dropping dummies. We know they lied about all these things. Because they later are saying, Project Mogul or what, I don't know what the current excuse is. But they have a whole string of explanations at this point,
They do,
which means
yeah.
that the previous ones were lies. So they're admitting to lies all the time.
Yes.
Why are they lying? I don't know. I don't exactly know why they're lying. There's of course the potential concern about, if there's a non-human intelligence involved, and our inability to defend against it if that becomes necessary. Those are two reasons for potentially having a lie,
Right.
and potentially covering this up or keeping it quiet. Another would be wanting access to the technology. You want access to the technology. You don't want another country to get the technology before you do. The third reason for keeping it quiet. There has been suspicion among people who have seriously looked at this that there is a bigger secret. Because I think the general feeling is that those reasons for keeping this quiet for 80 years aren't quite enough. And that there's something more dramatic happening that nobody has the answer to.
It's the UFO cabal.
And I'm starting to wonder if that's the situation.
Like maybe we're actually being controlled by aliens. Like maybe aliens are running the government. It's Roddy Piper. What was the movie?
They live.
They live.
Obey.
But I think that there's a potential. The potential is that there's a bigger thing that's not been revealed yet, that nobody has figured out.
Right.
And there's a potential for that. There's a bigger secret.
To be continued.
Thanks. Like, share, follow, comment, subscribe, support. What's your hot take on Travis Taylor?
I've got an exclusive for you guys if you want it about the
Absolutely.
Alaska.
We do.
Okay.
More at BigfootUFO.com.
All things unexplained.
So some of that, I think, sir, we'll save for closed session.